Yeah, comes on everyone. So last class we did for different shapes. Perfect. So let's go ahead. So let's say we have a paraboloid. X-axis, y-axis. This is your origin. So basically, this is your parabola. Y is equal to x square. It's a solid structure, 1, 1. So in 2-dimension, we call it parabola. In 3-dimension, we call it paraboloid. Meaning this would actually look like this. This is a hollow paraboloid. Able to visualize the shape? Anytime you put water in a bucket and rotate it, the shape which you get is this shape only. Find the center of mass. This here is a hollow paraboloid. Let's say this. Hope the question was clear, everyone. So the most important thing is to figure out, first of all, how will you take an element? Take a minute. I'll show you a bit. So just to give an idea, how do we take elements? We take elements as disks. We take thin disks. Try. You got a minute or two. Right, Poroja. We have one answer. So this is how we start. We take a thin disk whose thickness is dy at a height y, and this is x. So basically, that is x comma y coordinate. So for this will be the center of mass, which is 0 comma y. This is the center of mass of the disk. This thickness is dy. This radius is x. If you think about it, doesn't this look like a thin cylinder? Right, Ilhan, you got it. So the volume of this cylinder, small volume, will be pi x square into dy. And it is also given in the question y is equal to x square. So x square is y, so this is pi y dy. That is your volume. So what is the mass of this thing? Rho into dv, which is rho into pi into y dy. So y center of mass will be, so basically for each disk you have a center of mass. You're finding center of mass of these disks. The y center of mass of the disk plus mass of this disk by total mass of the disk. This will be y rho pi y dy. Y का coordinate goes from 0 to 1 because this topmost point is 1 comma 1 by rho pi y dy 0 to 1. We have rho by integral y square dy. Rho pi y dy 0 to 1. Rho pi will cancel. Y cube by 3. Y square by 2. You end up with 2 by 3. Therefore, the center of mass is 0 comma 2 by 3. It is symmetrical, so we know x coordinate is 0. Is this making sense, everyone? Did you actually observe the integration was easy, right? It is simply x power n integration. The headache was how will you choose an element? How will you find the mass? This is what I keep saying. In physics, the biggest headache is always this part. The actual integration will be always easy. Choosing an element and figuring out the thing is the important part. Have a look at this. Is this clear, everyone? Clear? Devansh, Ahana, Daksha, got this? Chainil, Arush, Ansh, Devika. Next one. Let's say we have a square plate. And we have a disk. Both are made of same material. This is 2r, 2r, and this is 2r. So basically the diameter is 2r. This point is your origin 0 comma 0. This is your x-axis. Find the center of mass. So a square plate and a disk are touching each other. The point of contact is your origin. Both are made of same material. The radius of the disk is r, the side of the square plate is 2r. Using this info, find the center of mass. This would be a proper mains level question. Everyone should give it a try. You got an answer, do type in the chat box to the co-host. That is wrong, Vojos. नहीं Purvaja. That is also wrong. Suppose if you have to guess this question, if I ask you like this, where is the center of mass? Right side, left side, at the center. What do you think is the answer? Will the center of mass be on the left side or right side or at the center, at the origin only? What is the logic? Left side, why? If you look at the square plate and the disk, who has more area? The square plate has more mass, right? So definitely center of mass should shift to that side. That much we know. How do we calculate? Pi minus 4 by pi plus 4. We have one answer. Others, try. I'll give another 30, 40 seconds. Raksha, think about it. The answer you got it on the right hand side. You have to be careful with the coordinates. Look at this. So the center of mass for the disk will be here. Let's call it M1. Coordinates will be minus r comma 0. For the disk, let it be M2. Coordinates will be r comma 0. So indirectly, the whole question has become you have to find the center of mass of M1 and M2. What is M1? It's a plate. So we take sigma into area, that is 2r whole square. M2 is sigma into pi r square. Therefore, x center of mass will be M1 minus r plus M2 into r by M1 plus M2, which is sigma 4r square. You can take out that r common, you end up with M2 minus M1 by M2 plus M1. Substitute the values there. Sigma pi r square minus sigma 4r square. Sigma pi r square by sigma 4r square. Sigma and r square will cancel. You end up with pi minus 4 by pi plus 4. If you look at here, pi is less than 4, so that actually numerator is negative. Pi is 3.14 minus 4, right? This is actually a negative number. So there, as expected, the center of mass is on the negative x-axis. Any doubts on this? So there. So if I combine some different shapes, this is how you do. Next one. Right, Adi, Jainil, Purvaja, Vihan. Yeah, all of you got it. Next one. Any doubts on this? Suppose if I have a solid cone and a solid hemisphere. Hope you remember the results. Do you guys remember the results? In case you forgot, you need to mug up. So solid hemisphere result is 3r by 8. From the center, 3r by 8. Solid cone, h by 4 from the center. Should know your results. 3r by 8 and h by 4. So I made an inverted ice cream shape like this. This is your origin 0, 0. This height of the cone is h. The radius of the cone is r. So the radius of the cone and the hemisphere is same. They both are made of same material. Both are solid. Find center of mass. I hope the diagram is clear. Now, this is what I was saying last time. If if you have a system and you can divide it into n parts, the center of mass of the n parts will be the center of mass of the whole system. Right, Ansh. That is right. You have one answer. Idea is the same. Find the center mass of the cone, find the center mass of the hemisphere, find the mass of the cone, find the mass of the hemisphere. M1 by 1 plus M2 by 2 by M1 plus M2. Be careful, the solid hemisphere coordinates will be negative. Let's see. So this will be 0, comma h by 4. Let the mass be m1, which is density, into volume of the cone is 1 by 3 pi r square h. This will be 0, comma minus 3r by 8. This mass is m2, which is density into 2 by 3 pi r cube, half of the hemisphere. You got an extra 3 in the numerator. So the y center of mass will be m1, which is rho 1 by 3 pi r square h into h by 4, so m1 by 1, plus m2 rho 2 by 3 pi r cube into y2 3r by 8 by m1 plus m2. Now from here, if you look at it, rho goes off, 1 by 3 goes off, pi r square, rho 1 by 3 pi r square, rho 1 by 3 pi r square, rho 1 by 3 pi r square. You will be left out with h square by 4 minus 3r square by 4 by h plus 2r. So we get h square minus 3r square by 4 into h plus 2r. Check your workings. In all of them, rho is common, 1 by 3 is common, pi r square is common. Now, examine a simple question would be like this. So if you take h is equal to root 3r, y center of mass will be 0. Means it will be exactly at the origin. Please have a look at the calculations. Like there's nothing there. If you know how to calculate mass and if you know center of masses, you're done. But you can ask a pretty nice question on this. Let me show you what they'll ask you. They won't ask you like this. They'll ask you like find the condition for equilibriums. Let me show you what it means. But any doubts on this? Anyone not clear with the mass? Anything that you're not sure? Please ask. Clear? Now in the C, listen carefully. If h 3r, then the center of mass will be above the origin. So this actually goes under little rotation, but the center of mass will be somewhere here. Now, if you displace this, if you disturb this, this guy will become like this. This is how it would look. This would be a normal reaction. This will be your Mg. You can clearly see here, both of them are not on the same line. It forms a couple. So what would happen? This will rotate this way. Now, did you see what happened? If I push it to the right, it will go to the right more, right? It will never come back. So this is unstable equilibrium. Isn't that the definition of unstable equilibrium? If you displace it, it won't come back. It will just keep going in the direction. If you see here, this n is rotating this way, mg is rotating this way. So the whole thing rotates towards the right side, clockwise direction. This is an unstable equilibrium. Suppose if h is less than root 3r. So normally when you go to a toy shop now, you'll find these kind of toys. No matter how much you kick them, they'll always come back. Ever seen a toy like that? Generally, you find kids' car toys. They make the base with a plastic and they put a balloon here. No matter how much you punch, this will go down, but it'll keep coming back. I'm sure you must have seen something of that sort. So in this case, the center of mass is below. You made the base heavier. Now, if you disturb this one, see what happens. This is a normal reaction. Center of mass is here, so mg will be here. So if you see this rotation, n is rotating this way, mg is rotating this way. So this rotation is backward. So if you push it to the right, rotation is to the left. This is stable equilibrium. This is how you want to make a toy. No matter how much you disturb, it will always keep coming back. There, so you can connect center of mass to the equilibrium which you learned in work power energy. Now there is the third case. What happens if h is exactly root 3r? So this they can ask as a matrix matching. Or exam they'll ask you find the condition between h and r for stable equilibrium. People will have no clue what the hell is happening. So in this case, the center of mass is at the origin. So when you displace this, your normal reaction and mg exactly are on the same line. There'll be no rotation, it just stays there. You push it, it stays there. It neither comes back, neither goes off. What kind of equilibrium is this? Neutral. Do you guys remember the three equilibriums we studied? Stable, unstable, and neutral. There, this problem has all three. Depending on the value of h and r, you can create either of them. Have a look at this. Like I said, this is a little based on torque and rotation, but I hope that much you're able to understand. N is pushing this way, mg is rotating this way. That's a clockwise rotation. They're forming a kind of a couple. People should focus. I can see some of you talking and getting distracted. Is this clear, everyone? Ariman, are you there? Yeah. So please focus on the class. Hope you're not distracted for with something. I don't see you answering anything or trying also. In case you're finding it little difficult to concentrate, I think you can take a break and you can leave. Ma'am will give you a call and we can refund you the fees. You can find someone else. Let's see the next one. Now, this is another important problems. Cavity problems. What happens if you make a cavity? Quite important reason. You will find a similar problems again in rotation, electrostatics, gravitation, magnetism. In any chapter, the moment you see the cavity, now the technique I'm teaching you is the same logic there. So this is a disk with cavity. Let's take two cases. Case one, this is a disk with a cavity. Case two, this is a solid sphere with a cavity. Now, technically, you can't see this cavity in a solid sphere, isn't it? It is inside. 3D structure, na? But okay, it's a solid sphere with a cavity. First, let's try to do the case one. So this point here is your center, 0, comma 0. This is your radius r. Means the cavity is exactly it's touching the center and the circumference. So basically, this is r by 2 ka cavity. Find the center of mass. Let's do case one, disk with a cavity. Take a minute. How will you figure it out? Then I'll show you the case one. Then I'll give you time for case two again. But you think how will you approach this problem if you have a cavity? Okay, you have one answer. Get this next one also, Daksha. Yeah, Ariman, that is wrong. Arush, wrong. Arey gods, think about it. If I make a cavity here, won't the center must be on the left hand side? Should get negative, na? How are you guys getting plus? Listen, I'll show you one technique. So whenever you get a cavity, this is the idea there. You take this cavity, the disk with the cavity. It's a simple idea, but this is the technique we are going to use in every chapter. This plus whatever is the cavity, bring it back again and fill it up. Then I will get a full disk. Now, can I say like this? The centromass of this plus this will be the centromass of this. Isn't that the whole theme we are playing from the beginning? So let this center of mass be here, x comma 0. This center of mass will be r by 2 comma 0, center of the disk. This center of mass will be 0 comma 0. Isn't the center of masses of all three? Now for the big disk, let the mass be m. What is the mass? Sigma into pi r square. Let this mass be m2, which is sigma into pi. Radius became r by 2 whole square. That means the mass is m by 4. So if you take a disk of half the radius, area is 1/4. Then this mass will be how much? M1 will be total mass minus M2, which is 3m by 4. If the total mass is m, the cavity wala ka mass is 3m by 4. Then you're done. So x center of mass will be m1 x plus m2 r by 2 by total mass m1 plus m2. This must be 0 because that is the center of the disk. So 3m by 4x plus m by 4 r by 2 equal to 0. X is equal to minus r by 6. This is how you handle cavity problems. You fill up the cavity, you'll get a nice symmetrical shape. Whose center of mass you know? You know the cavity ka center of mass. So the system 1 plus system 2 should give you the full system ka center of mass. Is the logic making sense? Now, can you try for the solid sphere? This is for the first part. What is the question? It's the same question, Ragod. There is a solid sphere with cavity. Instead of disk, if it is a solid sphere, then what is the center of mass? Try. Idea is the same. So what will change? Everything else will remain same. Mass will change. This will be rho into 4 by 3 pi r cube. It's a 3D sphere. So this will be rho into 4 by 3 pi r by 2 whole cube. It's a cube function, everyone. So mass becomes m by 8. So this guy becomes 7m by 8. Therefore, this is 7m by 8. This is m by 8. So x will be minus r by 14. Yeah. Please check your masses. Right, Vihan. Shana got it. Ahana got it. Ariman, you messed up the sign. Daksha, nope. Yep. See where it went wrong. So that is a technique. You get a cavity. This is what you do always. let me give you one more like this. Sure, everyone? Suppose if you take a solid cone and someone removed some material from inside. Just let me shade it like this. There. This is a solid cone with a conical cavity. So someone removed a cone from a solid cone. So this radius is r. This height is h by 2. So this h by 2 ka, it's a cavity, the green one. And the total height is h. Now find the center of mass. For convenience, I will take this point as origin. The bottom ka center, I'll take it as origin. Now find me the coordinates. Did you get the shape? From a full solid cone, someone scooped out a solid cone. Meaning, I can ask you another type of question also. What if I scooped out an hemisphere? I can ask you this also. So you can remove any kind of cavity. Get me the center of mass of this. The total height of the cone is h, and you removed a h by 2 cone from inside. So find the center mass of this weird shape. You have one answer. Ariman. Others. Right, Adi? We have two answers. Hope you guys tried it. You solved it, right? Or you guys remember the answer from somewhere? Solved it, then it is good. Try. Nee, just that is wrong. Vihan wrong. Ahana, you're right. God, Abhinav, how is the center of mass outside? What are you talking? Again, what is the theme? Theme is still the same. Take the cone with the cavity. Plus fill it up with that small piece. Then you get the full piece. So this center of mass I don't know. So 0, comma y. Now remember this height is h by 2. So where is the center of mass? H by 4, where h is the height of the cone. So this will be 0, comma h by 8. This will be 0 comma h by 8. So it is 1/4 of the height. That is the idea there. If the total height is h, then 0 comma h by 4. So what is the mass? Density 1 by 3 pi r square h. This is m2, 1 by 3 pi, radius is same, height is h by 2. So interestingly, this mass will be m by 2. Therefore, m1 is m minus m2. This is also m by 2. Both have equal masses. So therefore, y center of mass will be m by 2 y plus m by 2. Center of mass is h by 8 by total mass is equal to y center of mass, which is h by 4. M cancels everywhere. Y by 2 by h by 16 is h by 4. Y is equal to h by 2 minus h by 8, 3h by 8. Check. Right, Ishana. Meaning masses are equal. That is an interesting part there. Please check your calculations where you messed up. Clear? Any doubts? Janil? Clear with this? Arush? Let's see the next one. So you made a shape like this. So we have a plate like this. It's a square plate with a triangle removed. So this side is L. This is point A and this height is H. Now find L by H ka ratio if point A is the center of mass. Meaning, see, suppose if you make the cut too shallow, matlab if you cut it like this, if you cut it too shallow, then the center of mass will be above here, isn't it? It will be slightly up. If you make it too deep, then the center of mass will be somewhere here. So he's saying for a particular value, when you cut it in such a way, the center of mass will be exactly on the vertex. So this apex of the triangle must be the center of mass. That happens only for a particular value of L by H ka ratio. Is the question making sense? After removing the triangle, it is observed the apex of the triangular cavity becomes the center of mass. Then what is the ratio of L by H? Is the question clear, everyone? Try. This would be an advanced question. But again, whatever I taught you, the idea is still the same. It doesn't matter what is the origin. Question was find L by H. Why do you need origin? You can choose whatever you want. Your position of origin doesn't affect your answer. Think. I'll give 2 minutes. It's a good one. Hmm. Yeah, that's not the answer, Daksha. नहीं आ रहा. That's not the answer. Yeah, you get a quadratic. So what is the problem? You can't get a quadratic. You hate quadratics. You are a racist towards quadratics. Let's see. The idea is the same. So keep that in mind. Whenever you see a cavity, fill it up. You get a neat shape, and then you try to work out from there. So this is the shape. Plus, we have a triangle. This gives you a full square plate. Now, for a triangle, where is the center of mass? That you should know. In case you didn't know that, this is an isosceles triangle. For an isosceles triangle, the centroid will be along that bisector. This will be your center of mass, which will be in the ratio of 2:1. So this will be h by 3. For isosceles and for equilateral, this is R. For scalene, no, it won't be that way, directly aligned, but it is. So that is h by 3 there. So if I choose this point as origin, I'll take this point as origin for convenience. So this will be my center of mass, which will be 0, L by 2. If I take this as origin, so same thing. So this will be 0, h by 3. And for this thing, it is given in the question, this is the center of mass. So if this is origin, this coordinate is 0, h there. I know the coordinates for all three of them. This mass is m, which is sigma into L square. This is m2, which is sigma into half base into height. Base is L, height is h. This will be m1, which is m minus m2, which is sigma L square minus sigma LH by 2. There, I know the masses, I know the coordinates. We are done. So y center of mass will be m1h plus m2h by 3 by total mass. m1 plus m2 must be L by 2. That is the center mass of the full plate. Sigma L square minus sigma LH by 2 into h plus sigma LH by 2 into h by 3 by total mass is sigma L square is L by 2. Sigma is common in all. One L is also common. This guy would be LH minus h square by 2 plus h square by 6 L square by 2. This will be L square by 2 minus LH plus h square by 3 equal to 0. Check. So if you revise the notes, Vihan, you will know that. And this is what happens when you don't read the notes. For uniform triangular plate, center of mass is at the centroid. Now, but you want to prove, you can prove it. That will take another 5 minutes in the exam. So you will waste a lot of time. And if you do calculation mistake, that question will go off. And then end May, instead of getting IIT Bombay, you will get IIT Guwahati. You can go and kill mosquitoes there. It's a good IIT. Nothing bad with this. It has a good rainfall. It has a lot of mosquitoes. The airfare is also expensive. That is what 4 to 5 marks can cost you. Remember your results. Abhi question hua nahi. So divide by h on both h square. So this will become L by h whole square half minus L by h plus 1 by 3. Because you're asking for L by h ka value. No? Now it's a quadratic in L by h. So L by h is equal to 1 plus or minus root over b square minus 4 into half into 1 by 3 by 1. 1 by root 3. Now L by h, right, is 1 plus 1 by root 3. Because L by h is greater than 1. Therefore, L by h is not equal to 1 by root 3. Think about it. If L by h is less than 1, means what? H is greater, means you made a hole bigger than L, isn't it? Doesn't make sense. It won't be a plate anymore. There, this is your answer, everyone. Check if you have got it. Maybe you must have simplified it a bit. So root 3 plus 1 by root 3 or this. But have a look at this. I think if you got till here, question is over. Main idea is this. 3 center of masses, 3 masses. You're done. Now it is just a matter of putting in the formula and simplifying it. Please have a look at this. This would be an advanced question, an easy to moderate one. This is how you handle cavity problems. It doesn't matter. You give me any shape with any cavity, I'll fill it up. You have to get a symmetrical shape. That is there. This is the idea there. This is the theme when you handle a cavity problem. The same thing again you'll encounter in rotation. Then gravitation, we'll see. Clear? Next one. Can I turn the page? Next one. So that is about locating center of mass with cavities, different shapes and stuff. Next thing. Velocity and acceleration of center of mass. So we know the position vector RCOM is sigma mi ri phi sigma mi. Differentiate both sides with respect to time. Then this will become dr by dt, which is nothing but velocity of center of mass. Sigma mi differentiate dri by dt. So velocity of center of mass is sigma mi, dri by dt is vi. This is how you find velocity of center of mass. So same, the formula looks like the same. M1 R1 M2 R2. Here it is M1 V1 M2 V2 by M1 plus M2. Now, if you look at there something interesting, you will find sigma mi VCOM is M1 V1 bar plus M2 V2 bar and so on till Mn Vn bar. This will be total mass into velocity of center of mass. This will be P1 bar, P2 bar, and so on. This is the momentum of the system. So momentum of center of mass is momentum of the system. That means if there are 1,000 particles all going in random weird directions, and if you want to find the momentum, there's no need to calculate for each and every one. If somehow you can find the velocity of center of mass and mass of center of mass, then the momentum of the system is momentum of center of mass. So you can just treat the center of mass like a particle, keep all the mass there, and you can get the momentum. And that is there. Now, if I differentiate this guy again, if I differentiate dVCOM by dt, this becomes acceleration of center of mass, which is sigma mi dvi by dt by sigma mi. So we get acceleration of center of mass is sigma mi ai by sigma mi. So if you see the formulas for acceleration and velocity rate, it is something similar to position. M1 R1 M2 R2 for velocity M1 V1 M2 V2 for acceleration M1 A1 M2 A2 and so on. Have a look at this page. Clear, everyone? Now here you will see something else. So if you bring all the mass to one side, sigma mi acceleration of center of mass, this is M1 A1 plus M2 A2 and so on till Mn An. What is M into A? M1 A1 is the force on the first particle, M2 A2 is force on the second particle, and so on till force on the nth particle. This will be total mass into acceleration of center of mass. So this is nothing but net force. This is your Newton's second law of form, isn't it? That means till now, when you're writing F is equal to ma for a body, every point on the body is going with different acceleration. So that A which you have calculated till now is as center of mass acceleration. For example, tell me one thing. If you take a ball like this, and if you push with force F, do you think when this ball is rolling and going, do you think all have same acceleration? Every point is having different acceleration, right? But then when you write F is equal to ma, you are writing A of whom exactly? A is not for any one point, isn't it? That A is actually the center of mass acceleration. So this is actually the proof for the center of mass. Center of mass was actually derived this way. See the derivation for center of mass. F is equal to ma. We know F is equal to F1 plus F2 plus Fn. F1 is M1 A1 M2 A2 Mn An. So they did all reverse actually. So from here we got the acceleration of center of mass. Now integrate. Now if you integrate this, I will get velocity of center of mass. If you integrate again, I'll get position of center of mass. The center of mass is actually derived from Newton's second law. You're getting this? You take the F is equal to ma equation and you derive it, integrate it 2 times. See, I differentiated right here. So if you integrate 2 times, I'll get it back. So center of mass is not some weird concept, that just came out of nowhere. It was actually proved from Newton's second law, F is equal to ma. So from this we can see, so F external is ma center of mass. So till now the formula which we are using, F is equal to ma, F is equal to ma, that A is the acceleration of center of mass. So if F external is 0, this implies acceleration of center of mass is 0. This implies velocity of center of mass is constant. If acceleration is 0, velocity is not 0, the center of mass is constant. Therefore, momentum is constant. So if there is no external force on the system, momentum is conserved. This is your second conservation, everyone, law of conservation of momentum. The first conservation was energy conservation. When the work done by external force is 0, energy is conserved. If the F external is 0, then the momentum is conserved. So here, a better version of this thing is, if F external in a particular direction is 0, let's say in the x-axis force is 0, then momentum is conserved in that direction. If total force is 0, then momentum is conserved in every direction. Momentum of the system with respect to center of mass. Tell me one thing, if you add all different momentums of the particles, yes, right, Bhavaja. If you add the momentum of each and every particle, in the end you will realize that is the same as if all the mass is at the center of mass going with VCOM. Now tell me one thing, momentum of the system is momentum of center of mass. If you go and stand on center of mass, you will think center of mass is going with what speed? 0, right? It is always at rest, it is below your feet. So momentum of the system with respect to the center of mass. So if you stand on the center of mass and if you look at all the particles, is always 0. This is the kind of theoretical questions I can ask you. Check it out. Clear, everyone? Any doubts on this page? Devika, clear? Nikhil, clear? Niharika, got this? Ariman, clear? Tanish, there's no Tanish. Sharman, clear? Next thing. So basically, center of mass behaves like an independent particle of its own. So you can study its own motion separately. So velocity of center of mass is simply dr by dt. Acceleration of center of mass is dvcom by dt. Or vcom dvcom by dr. Kinematics, everyone remember? So you can just treat center of mass like a particle and solve. Everything you learned in kinematics will come back again. So if acceleration of center of mass is constant, then you can use your 3 equations also. V is equal to U bar plus A bar T. This will be final velocity of center of mass, initial velocity of center of mass, acceleration of center of mass. S is equal to ut plus half at square. Center of mass, center of mass, center of mass. V square minus U square is 2as. So if you know your velocity and acceleration of center of mass, and if A is constant, it just behaves like a projectile kinematics. You can just treat it like another particle and solve the problems. Have a look at this. Is this clear, everyone? Let's say a question on this. Let's say we have two particles. This is particle A of mass 2m. This is particle B of mass m. Both are projected with 20 root 2 meters per second, 45 degrees. B is projected 25 meters per second, 37 degrees. So this guy will go something like this. This guy will go something like this. So at any point of time, they will have their center of mass is also moving, right? The center of mass also will be going in some weird direction. Gravity is there. So find acceleration of center of mass, velocity of center of mass at time t. And h max of center of mass. That's a good one. What is the maximum height reached by the center of mass? If you look at this motion here, I think this will go something like this. This will go something like this. So the center of mass will go in some weird way. Let's get this. Let's get the acceleration first. Purusa. Get guess the other two. That acceleration is the easiest one. Yeah. Try to give the vector form. Acceleration is minus gj cap. Right. Acceleration is minus g. Na? Both the particles will have same acceleration. If you got that, get the next one. Find the velocity of center of mass after time t. Try. I'll give you a minute or two. There. The kinematics with center of mass. It's a vector quantity, right? God. That may be right. I don't know the velocity answer. First, let's see the acceleration part. Acceleration of A is minus g j cap. Acceleration of B is also minus g j cap. So projectile motions both have same acceleration. So acceleration of center of mass will be 2m minus g j cap plus m minus g j cap by 2m plus m. So you can clearly see acceleration is constant. Yep. Then if you look at the velocity here, this is 20 root 2, 45. This is for A. This is 25 meters per second at 37 degrees. This is B. This is m and 2m. So let's find the velocity first. What is UA? 20 root 2 cos 45, 20 I cap plus 20 j cap. So this is the initial velocities. What is UB? 25 cos 37. So minus 25 cos 37 because it's pointing backward plus 25 sin 37 j cap. Cos 37 is how much? 4 by 5 minus 20 I cap plus 15 j cap. So what is the initial velocity of center of mass? This is you, huh? I didn't ask you this. Initial velocity of center of mass. You could actually find final velocity of A, final velocity of B and calculate directly. But I want to show you something here. So this would be m into UA, which is 2m. This is 2m. This is m into UB bar by 2m plus m. So you get the initial velocity of center of mass will be 2 into 20 I 20 j plus m into minus 20 I plus 15 j by 3m. M gets cancelled. This will be 2 into 20, 40 minus 20, 20 by 3 I cap. 2 into 20, 40 plus 15, 55 by 3 j cap. You can clearly see here, this is your x component and this is your y component. The reason why I did this, do you guys remember Hmax ka formula? Hmax is uy square by 2g, isn't it? How do you find Hmax? Hmax depends on the initial velocity, isn't it? There. So this gives you the Hmax there. 50 by 3 whole square by 2g. One common mistake what people do that I see, meaning not all, some people do this. They think like this. So when this is flying here and when this is flying here, they find this Hmax, they find this Hmax and then they try to find the Hmax. Can you tell me what is wrong with this? They take the Hmax of both the particles and then they find the center of mass. Chalo, masses are different, but that is okay. Both of them won't reach the Hmax at the same time, na? Both the particles won't reach their respective maximum heights at the same time. Maybe when this is reaching Hmax here, this particle is still here only. You're getting the point? So there is no guarantee that both the particles will reach the Hmax at the same time. So you can't do it normally. You have to find center mass and finish it off. This is how you find Hmax. That would be quite a good one. And then you're done. So velocity of center of mass will be initial velocity of center of mass plus acceleration of center of mass into time. So this is 20 by 3i plus 50 by 3 minus gt j cap. That's what I said. Once you know your velocities and accelerations, I can use v is equal to u plus at, right? Or another way to do is find the final velocity of A separately, find the final velocity of B separately, and then do m1 v1 bar plus m2 v2 bar by m1 plus m2. That also works. बट इन दैट केस एच मैक्स के लिए वापस यू कैलकुलेट करना पड़ेगा. You're getting it? You need to find the initial vertical component of center of mass. So basically, this is what is happening. The center of mass is behaving like a new particle whose velocity, this is uy, this is ux. So this itself is behaving like a new projectile motion. Making sense? So the center of mass is behaving like an independent particle and it is flying its own projectile motion. Please have a look at this. Clear? Take a break. Come back by 7:10. We'll continue from here. Any doubts so far, you can ask me. Second method, I was saying, find the velocity of A directly in a final. 20 I cap plus 20 minus GT J cap. Find VB directly final and then do M1 V1 bar plus M2 V2 bar. Then there's no need to find initial velocity. Take a break. You can keep your cams on. Come back with 7. You have any doubts, any queries so far, you can ask me. Okay, back in 10 minutes. Hmm. Yeah, sure. Camp on everyone. Let's see one more like this. We have an Atwood machine here. Let's say this is 2m. This is m. Released from rest. Find the acceleration center of mass. Right, Ashana. Easy one. Get this. Right, Vihan. Hope everyone remembers the formula for this. Atwood machine acceleration of the block will be m2 minus m1 by m2 plus m1g. You can also use net force pooling method, or you can write the equation also. So this will be g by 3. Now be careful. The most common mistake what people do is they forget the sign. So acceleration of center of mass will be 2m. 2m is not going up, it is going down. So minus 3 by 3 j cap. And the m is going up, so plus g by 3 j cap. The common mistake people put both plus signs only. This will be g by 9 j cap. Check. So be careful with that. 2m is going down and m is going up. Clear? That's an easy one. Next thing. Stability of systems. Suppose if you take a block like this, and keep it on the floor, do you think this will remain at rest? The mass will be somewhere here, center of mass. So mg will be here. The normal reaction will be somewhere here. So this thing won't remain at rest. This will topple. Again, this is kind of based on torque. So the logic here is this N and Mg are not on the same line. So they produce a torque. They form a couple basically. Since N and Mg are not on the same line, the system rotates. We call this thing toppling. But the same thing, if I add one more block here, something like this, do you think it can be at rest? Now there is a possibility, right? So basically this guy and this guy ka center of mass, somewhere it will be here now. So it will be like this. So this can be at rest. There is a possibility this can be at rest. So what changed? So the idea was this. As long as the mg vector passes through the passes within the boundary of the surface in contact. So whatever surface is in contact with the ground, as long as your mg passes through that, you're safe. Boundary of system remains at rest. So whenever you want to keep something, at rest and weird position, this is the thing. I'm pretty sure you must have seen a toy like this. Uh, did you ever see a toy like this? Never seen this? You have a bird here. If you look at this entire bird, right, is just balanced on the beak. We used to have this toy when I was a kid. You can get this in Amazon. You'll get it for 500 rupees. Just search balancing toy karke or something like that. So I used to have this, when I was a kid. I used to be very curious, like what is there, and one day I finally broke it. So what I found here is you have a metal piece here, you have a metal here, and you have a metal here. So these three ka center of mass is somewhere here. Getting it? So it's kind of like this. And when you look at this mg vector here, this passes within this boundary here. This is what makes sure it is always in equilibrium. Wait 1 sec, I must be having this somewhere. If you see my screen here, can you see this? You can see this bird here. I can displace this. This thing I got it from Amazon. So you see, it just is on a fingertip actually. This entire thing is balanced on my fingertip. This is the full toy. You can see how the shape looks. The wings are, if you see now, the wings are quite ahead. The tail is backward. So these things are heavy actually. So the center of mass is somewhere near the beak. So when I put it near the fingertips, if you can I put it on my thumb, it remains in equilibrium. You can twist it, you can do anything, it doesn't fall. You can see how much did I tilt it? I tilted it this much. So there, you will get this in Amazon. I bought it from there. You can search balancing toy. You'll find it. You have more interesting toys than. Let me show you something more. The same one. There. This is what I was saying. Look at that. There, you can twist it, tilt it, do anything. It doesn't fall. It's in super stable equilibrium. You can do even something more interesting. Look at this thing.
Hello everyone, in today's video I'm gonna show you another cool experiment with gravity. All using two of those, and it doesn't
So we have a rubber band, scale, and a hammer.
And then I'm gonna take the hammer and put it, we're gonna do it this, and I'm
Now
gonna
see.
put it this way, like this. Check this out.
It remains in
The
equilibrium.
hammer is hanging.
So the idea here, you know what? That hammer is there. The metal part is the heaviest, right? And if you observe, that is under the table. That means the center of mass is still passing through that scale on the table, isn't it? If you see how that shape was made, that hammer ka metal part is under the table. So the center of mass is still under the table, isn't it? So that means the mg ka vector ka line is passing through the upper part of the scale, isn't it? Now, this is still fine. Now see, you can go to extreme.
Actually, put this.
You can bring it even more
on
extreme.
the edge, like right here. It's still hanging. Yeah, it's
Still hanging because the center of mass is still passing through the scale, the table.
Obviously, nothing under here, and well, there you go, explanation. So this ruler is trying to fall down, so is the hammer.
This is a very simple thing. You can try at home also.
Balance the ruler up, and that's how you get this cool gravity.
This guy, this is also pretty good.
People ask if it's glued, if there's steel rods. A lot of people really don't understand that it's just balanced.
These mind-bending rock formations are held together with nothing but gravity. Rock balancing art predates the Bible. It's one of the best turned him into an internet phenomenon.
So
Noticed first, the structure that probably got me noticed first internationally was kind of this orb structure that I made. And it's just
this guy made the whole thing. Just standing on that small base.
Balanced on a really tiny one at the bottom.
That is more fun, right? Destroying it.
Drives is to make the formation.
Look at his job ka profile. Michael Grab, rock balancer. That is how you create your own job.
And as impossible as possible. I process.
Look at the shapes he makes.
To my process while I'm building is like, oh no, that's impossible. That'll never happen. Especially when I
there, he just, you know,
put it on a tip.
the main idea is that as long as you can make sure the center of the system is passing through the base, they remain in equilibrium.
Anyone can make rock piles, but Michael has spent the last 12 years perfecting the art of balance.
I started.
So there, I'll post that in the group anyway. You can watch it more. Aram se. This is what I was talking about, the stability. So the main catch is that you need to make sure that line is right, is passing through the center of mass, and you're safe. So let's see a question based on this. So let's say we have 4 wooden planks. Like this. I'm pretty sure in school you must have played like this. You kept books on top of another, and you must have placed it on a table like this. So we have 4 identical planks of length L. Now, if you balance them properly, right? So this A is the tip of this plank. This is the maximum distance you can push them. So the question is, find the maximum X. So how far can you push these planks so that it still remains in equilibrium? Meaning, if you don't put them properly, there is a possibility it will become like this, isn't it? The whole thing will start falling off. You don't want such thing to happen. If everything is at rest, what is the maximum or the farthest distance you can push this such that system does not, or system is at rest? You can keep it however you want. You can keep like this, you can put like this. If you want, you can put it like this. Do whatever you want. I want this to go to the farthest. What do you think? Take a minute, then I'll explain you. So the catch is this: the center of mass or the upper part, right, must pass through the base of the lower part. I mean, just to give an idea here, that's not the answer. That's not the answer. I'll explain for the first part. If you take the upper plate, plate 1, where is the center mass of plate 1? Here. So this mg will pass here. Since you want to keep it at the extreme position, the plate 2 must pass just at the boundary. Make sense? The center of mass of the above part should just pass through the base of the below part, isn't it? So there should be some kind of a thing here to be below the center of mass. So this is how you keep your plate 2. Is this making sense? Then the plate 1 will be at rest. Now plate 1 and plate 2, for plate 1 and 2, where is the center of mass? Somewhere here, C1, 2. So remember, this distance is L by 2. Now again, that means the center of mass of these two, this will be the mg here. There should be someone below this, isn't it? That means your plate 3 must be exactly below this point here. Is this logic making sense, everyone? So whatever you're piling up on the top, uska center of mass, the mg vector, should pass through the edge of the plate below. Isn't that the logic? So how much is this distance then? This will be L by 4. Why? C1 and C2 ka midpoint it is. Agreed? Now what about the next plate? Now where should you keep the fourth plate? Now you need to keep the fourth plate. So this is C3. So you need to keep it at the center of mass of C132. So somewhere here, you need to keep it at the center of mass of 1, 2, 3 ka plate. Now, if you look at this calculation here, this is C3, this is C12, this is mass M, and remember 1 and 2 ka mass is 2M. If I take this as origin, This is minus L by 2 comma 0. Why is that L by 2? Because C3 is the center. This is L by 2. So if you try to find the center of mass of these two, center of mass will be somewhere here, which is 2m into 0 plus m into minus L by 2 by 3m minus L by 6. So this distance is L by 6. Meaning these two ka center of mass will be somewhere here. So the fourth plate must be here. This will be L by 6. We have to be careful here. Huh? This is the mistake people do. They think it is a job GP. They think it is L by 2, L by 4, L by 8, L by 16. No, it is actually HP. If I keep one more plate, I didn't ask you that, but if I keep one more plate, now see what happens. C4, this will be C1, 2, 3. This is M and this is 3M. You will notice now the center of mass will be somewhere here. Now this distance will be L by 8. If I keep one more plate, C5 and C1, 2, 3, 4. Now this distance will be L by 10. You're getting? So it forms a harmonic progression. So the next plate will be L by 8. If I keep one more plate, L by 10 and so on. That is because on the right hand side, mass is increasing linearly, right? 2m, 3m, 4m, and so on. Is this making sense, everyone? So for our question, we need only how many plates? 1, 2, 3, 4 plates only. So in our question, x will be L by 2 plus L by 4 plus L by 6 plus L by 8. This is 25 L by 24. So that is the main idea there. How many ever plates you keep, all those plates ka center of mass, that mg vector should pass through the edge of the bottom plate. Is that making sense, everyone? Why edge of the plate? Because you asked for maximum x. So meaning this system, right, is almost on the verge of, getting disturbed. All you need is a little push and everything will fall. Have a look at this. Ask me if you're confused. It's a good question. Do remember the result. Saves you time in the exam, or else you have to derive. And another biggest mistake is this. People find these two and then they'll assume L by 8. They think it's a GP. That's the mistake. Clear, everyone? So this is based on stability. So you can play around questions like this. Next one. Any doubts? Anyone not convinced with this? Abhinav, Adi, Arush, clear with this? Ansh, Vihan, clear na? Vignajit, Ojas, Surya, Pratik, Devansh, Devika, clear? Clear na, Devika? Next one. This is another standard problems. Man walking on the plank. Let's say we have a plank here on a smooth surface. L is the length of the plank. Mass is m. There is a person of mass small m. Ground is smooth, but this is rough. He has to walk, na? If that is not rough, he can't walk. So the man starts walking on the plank. So the question is, find the distance moved by the plank when the man walks to the other end. Now you need to ask yourself, why does it move? What is the direction of friction on the man? When the man walks, how is the friction on the man? Forward, right? Right side. Friction is making him walk. Same friction will act backward on the plank, isn't it? So every time he goes forward, the plank also keeps getting pushed backward. So Planck actually comes back. Give it a try. Take a minute, think about it. Then I'll show you one more model on this. I'll give you a general process how to do this, but you first give it a try for a minute. Anyone didn't get the diagram, please ask. Right, Purada. It's another one. Let me show you one here. So first thing you need to understand, when the man is walking, the friction is internal force. So here F external is 0. Therefore, A center of mass is 0. Therefore, velocity of center of mass is constant. But in our problem, initially everything is at rest. So here velocity of center of mass is 0. Therefore, center of mass does not move. Now, whose center of mass? Center of mass of man. Man is walking, Planck is going, but the center of mass of the man plus Planck is at rest. Is that making sense? Therefore, the displacement of center of mass is 0. So you have to show you this in a picture. This is how it would look. So man is here. So the center of mass must be somewhere here. So when the man starts walking, the Planck, let's assume it has gone x backward. And the man has come to this corner. So you will realize the center of mass is still here. Now in this process, let's say the Planck has gone x backward. So how much did the man actually walk? Did he really walk all the distance L? He walked only L minus x, right? Right. So then, so delta x of man is L minus x I cap. Delta x of Planck, Planck has gone backward minus x I cap. And delta x of center of mass is 0. Do you remember this formula I taught you? In the beginning, delta x center of mass, the change in displacement is m1 delta x1 plus m2 delta x2 by m1 plus m2. Do you remember this? We did this in the position vector map. So we know delta x center of mass is 0. Man ka mass is small m. Man ka displacement is L minus x. Planck ka mass is capital M. Planck ka displacement is minus x by m plus n. There, this is the formula which you use. So you don't find individual displacement, you find the change in displacements. So we get x is equal to ml by m plus n. Now this method you can use even if you have 3 to 4 people moving at the same time. This is how you approach this. So in this problem, step 1, let the Planck go backward by x. You can take forward also. It doesn't matter, the science will take care. Step 2, calculate displacement of all the objects. Step 3, use this formula. Delta x center of mass is sigma mi delta xi by sigma mi. There. These are the 3 steps you need to use to solve. Suppose the same problem, if they say like this, if the man is walking with speed u, relative to the plank, so instead of, is when he goes to the corner, if he's running, then I can find the speed of the plank also. The speed of the plank will be L का place में u आ जाएगा बस. There. Now let me give you one more question like this. Clear with this? Now you guys try this. Same question, but this time there are 2 people. We have a plank of mass m. We have person A. We have person B. The ground is smooth and the length is L. So A and B are walking towards each other. A ka mass is m and B ka mass is 2m. Plank ka mass is m. So A and B walk towards each other and exchange places. So B goes to the left side and A goes to the right side. Find distance moved by the plank. Again, you had to tell me whether it is going right or left also. Huh? Yeah, you have to forget the value also. Right, Ishana. नहीं आना. Yeah, Abhinav. What do you mean by minus? Is it left or right? Surya, masses are given, Ray. What is small m? Let's see. You can see the question and get a feel, like, because this guy is heavier, We know the plank will go to the right side, isn't it? But let's stick to the assumption. Let's still assume it is going backward. The science will take care of it. In case you have taken forward, nothing wrong. So after some time, this would be the scenario here. A must have come here and B must have come here. So let this thing travel X. So A has traveled L minus X. So if you look at the displacement, so A traveled L minus X I cap. How much did B travel? B traveled L plus X, no? So B traveled minus L minus X I cap. The plank traveled minus X I cap. If you have taken it forward, you would have got B ke liye L minus X and A ke liye L plus X. And then you're done. So delta X center of mass of A is MA, L minus X, mass of B is 2M, minus L minus X, mass of the plank is M, minus X by total mass 4M is 0. This would be L minus X minus 2L minus 2X minus X is equal to 0. We get X is equal to minus L by 4. The minus indicates the direction I have taken is wrong. I took it left, right? It is actually the other way around. You can do that, Puruja, it works. It will be lengthy, right? Meaning when you stop A, you have to treat B and the plank as one system. So here negative indicates opposite of what we assumed. So we assumed backward, but actually it is going right. Yeah, so therefore answer is L by 4, right? Clear, everyone? Makes sense? I can do this with any number of planks. You can even keep one more person C in the middle and say C is also going to the right. Then you'll get XC also. Now, every time the same question, right, they can ask you in another way. They will say there is a balloon here and there's maybe some insect or something here which is climbing this balloon here. Let's say this is M, capital M. So balloon in equilibrium. And this length is L. So the question will be, if this insect starts climbing the balloon, by what distance the balloon will come down? So when this insect starts climbing there, this is what will happen to the balloon. It will become like this. The insect must have reached here. Now, if you think about it, if you just rotate it by 90 degrees, doesn't this look like a plank and a man walking on the plank? So the result is still valid. So the distance moved by the balloon here will be ml by m plus m, where capital M is the mass of the balloon and insect is small m. So they can ask question like this also. So you need to understand it is the same thing. They can do even something of this sort. Let's say you take a wedge here with a circular arc like this. And let's say we have a ball here, mass m. And let's say this is your radius r. Now, if you displace this by small amount, so this was x, the ball must have reached here. So this will be r minus x. Again, the same question, they'll ask you how much did the wedge go backward? Same thing, x will be m into m plus m. In place of L, we have r, isn't it? Because you're only finding the x coordinate, it doesn't matter what is the y coordinate. This is making sense, everyone? So when the ball starts rolling from here and comes down to the center, the question will be, by what distance did the wedge go backward? So this again becomes like a question where we have a plank here of length r, and the man is walking from left to right. So all these questions are same. Only how you frame them matters. Check it out. Sure, everyone. So this question can be asked like multiple ways. Next thing. Potential energy of center of mass. Let's say there are n particles, mass m1, height h1, mass m2, height h2, mass mn, height hn, so on. So if I ask you to find the potential energy of the system, what will you do? You find the potential energy of each particle. You will say m1 gh1, m2 gh2. This is what you do. You calculate for each one and then you just add them up. mn gHn. Now, if you take out G common here, you will realize this is G into sigma mi hi, which is nothing but capital M into HCOM. This is nothing but potential energy of center of mass. Quite a useful one. So if you want to find the potential energy of a system, you need not calculate for each piece. You just take the center of mass, put all the mass there, find its height and finish it off. Example. If someone comes and asks you, there is a solid cone here, mass m and height h, and they ask you what is the potential energy of this cone. You know the center of mass, h by 4. So the potential energy of this cone is mg h by 4. Do you guys remember this? We did in the work par energy wo chain problems ke liye we did. We used to replace all the mass at the center and we used to say potential energy of the chain is mg L by 2. For example, if someone takes an half disk and they ask you what is the potential energy of this half disk. So this is the center of mass. I hope you remember the result. This is 4r by 3 pi. So the potential energy will be mg. So you can replace that whole disk with the mass m at the center of mass and solve. Quite useful. So it doesn't matter what kind of shape you give me. If I know the center of mass, I can find the potential energy. So momentum of the system is momentum of center of mass. Potential energy of the system is potential energy of center of mass. So center of mass is helping you a lot. Have a look at this. Let's see how they'll frame a question on this. Any doubts on this? Turn in the page. All clear? Jainil? Aryaman? Clear? Arya? Pratik? Sharman? Clear? Great. Let's say we have a semicircular pipe. Inside this, we have a chain. So we have a chain of mass m. The radius is r. Then someone gently disturbed it. Just maybe gently touched it, and then what happened? The chain started coming out. This is what happened. The entire chain came out. So the question is, find the speed of the chain. So meaning this is what happens. See, when you disturbed it, after some time, the chain was like this, then it was like this, then it was like this. So it is just sliding out completely. So find the speed of the chain when it is completely out of the pipe. How do you do this? Again, you can use your work per energy, everything is valid. Now in work per energy, what you used to do, loss in PE is gain in KE. But how do you find potential energy? Center of mass. Previously, we used to have blocks and particles, so you never had a problem. But if you have extended shapes, how do you find potential energy? You have to use center of mass. नहीं अंश इतना अच्छे से सिंपलीफाई नहीं होगा. It's not tough, but it won't get simplified that easily. Under root gr by 8 plus pi. Okay, fine. Maybe I think you must have simplified it further. Let's see. Try. I'll give you another 30 seconds. Let's see. So look at this thing. So this is your initial state and this is your final state. So this is my state 1. This is my state 2. So initially the center of mass is here. This is at a height of 2r by pi. It's a semicircle. Now, what is the length of this chain? Circumference, no? Half circumference, pi r by 2. Now, where is the center of mass? It will be somewhere here. Pi r. So this is pi r by 2. So think of like this. That means the center of mass from this height went down to this height, no? So what is the loss in potential energy? So loss in potential energy is gain in kinetic energy. That's it. Or else you have to actually take NLM and then integrate and do this stuff. It's quite messy. So mg, what is the total loss? 2r by pi plus pi r by 2 is equal to half mv square. There, you can simplify this further. You'll get the answer. That's your velocity. You'll get it in one step. You should know the center mass of semicircle. But when the chain comes out, it becomes a straight line. So it will be the center. Is that making sense, everyone? Easily. It's like 2 to 3 steps, but there. So this will be 2gr by 2 by pi plus pi by 2 ka root. That's your answer. Any doubts on this? All got this? Now here you have to be careful. Now because we kept on saying momentum of the system is momentum of center of mass, potential energy of the system is potential center of mass, people will start assuming kinetic energy also it works. So it fails actually there. Kinetic energy of the system need not be equal to kinetic energy of center of mass. So center of mass works when the functions are linear. Momentum is mv power 1 works. Potential energy mg h power 1 works. kinetic energy half mv square doesn't work. So because center of mass is what, m1 r1 m2 r2, it's a linear function, need not be equal to. So just be careful with that. Just because potential and momentum are working, don't think it will work for that. Let me give you an example. Let's say we have a block m going with velocity v. We take another identical block going with velocity v. Now, if I ask you to find the velocity of center of mass, this will be m into v minus m into v by 2m, 0. Therefore, kinetic energy of center of mass is 0. But if I ask you kinetic energy of the system, remember kinetic energy is a scalar quantity. It is half mv square 2 times c. They are not equal. So be careful. Potential energy of the system, replace with center of mass. Momentum of the system, replace with center of mass. Kinetic energy, you can't. So, but there is a relation between them. We will prove this in rotational mechanics. So kinetic energy of the system is kinetic energy of center of mass plus kinetic energy about center of mass. Let me explain you each term. Kinetic energy of center of mass meaning treat center of mass like a particle and find its kinetic energy. So that will be half total mass VCOM square. Kinetic energy about center of mass meaning calculate kinetic energy of all particles with respect to center of mass, meaning stand on the center of mass and find the kinetic energy with respect to center of mass frame. That will be sigma of mi, velocity of the ith particle with respect to center of mass ka square. So velocity of I with respect to center of mass is velocity of I with respect to ground minus velocity of center of mass with respect to ground. So stand on the center of mass, subtract the center of mass velocity from everyone, then you'll get new velocities, then find the calculated energy. It's quite messy actually. So we'll not use this generally. For potential energy and momentum, we will use center of mass. For kinetic energy, generally we'll avoid this. We will just try to calculate it normally. It's a mess. But keep this in mind, because till now I kept on saying they're equal. There's a high chance, you in a flow, you will think they're also equal. Center of mass concept works when the functions are linear. Clear with this? So if you see in this, we calculated center of mass position, we calculated for particles, we calculated for continuous bodies, then we calculated the motion of center of mass, velocity of center of mass, acceleration of center of mass. We had stability, equilibrium, and energies of center of mass. So kind of this is the whole thing about the center of mass part. So next class when we catch up, we are going to continue from here. We will still do maybe, center of mass slowly will be drifting into momentum now. So we have law of conservation of momentum. We have some pretty good problems. So now we will use law of conservation of energy, that is work per energy and momentum ka combination problems. So next class we have some good ones. Okay, so with that we'll wrap up for the day. So do make sure to go through this. We did almost 20 problems. Okay, so if you have any doubts, anything else, you can stay back and ask me, or else you're free to leave. So I'll see you guys on Thursday at 5:30 as usual. So any doubts, anything, stay back and ask, or else you're free to leave. So